Everyone, July 20th. Alright, asteroid collision. We're given an array asteroids of integers representing asteroids in a row. For each asteroid, the absolute value represents its size and the sign represents its direction. Positive meaning going right, negative meaning going left. Each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If both are the same size, both will explode. Two asteroids move in the same direction and never meet. So in the first case, they all start at the same position, I think. In a row for each asteroid, absolute value. No. This is the position. So 10 and minus 5. 10 destroys minus 5. So it's 5, 10. Destroy. This will destroy 2, become minus 5, and this will become 10. Okay. So we have a bunch of values, right? We have a bunch of values. V1, V2, Vn. Okay. And some are positive, some are negative. Of course, all the positives goes in one direction. Okay? All the positive goes one direction, all the negative goes the other direction. And positives and negatives. So what we need to find are, if everything is positive, nothing will change. If it's negative, nothing will happen. It only happens if we have pairs, right? A positive and negative. And it has to be a positive and negative. If it's a negative and positive, I feel like it's like a stack, you know? I have 5, I have 10. Now we go minus 5, so we look for the top of the stack. If the top of the stack has the negative value, we just keep pushing, right? And then if the top is a negative value, we'll always keep pushing because negatives go this way. So if mine is a negative, I can keep going. If I'm a positive, that will never meet, right? So only if I am a negative myself and I see is this a positive. If this is a positive, if it's positive, we keep going. So only this case. So we'll pop and then we push. So yeah, I think a stack seems to be sufficient for this. Okay, let's try a stack. Try a stack, see if the stack works. So again, the ideal is we have a stack. If it's a negative, then we always, it's fine, right? So we say for, the first one would definitely be pushed in, right? And then we say for I in range 1 to land asteroid. We say if stack, you know what? I need to check stack anyway. So yeah, might as well just say for A in asteroids, right? If not, no. While stack and stack. Hold on. If A is larger than 0, right? Larger than 0, it's not going to be 0. So if A is larger than 0, the asteroid is always going to the right. Then it doesn't really matter. Stack.append A. It doesn't matter. If the stack, top of the stack is going left, it's a negative, perfect, we can add it. If it's positive, we can add it. It's fine. So it's only when this, okay, then we need to check the stack. Check. So while stack and the top of the stack is a positive, because A is negative, right? If that's the case, then we will pop it, right? And then the two we need to find. So we can say pre equal to this, right? So we say if pre plus a is equal to 0, so they just annihilates, right? If they annihilates, then perfect, break, come out. Otherwise, if pre plus a is larger than 0, right? What does this mean? Well, pre plus a is larger than 0 means the pre is in the stack. So whatever is in the stack is larger than whatever is a. So the larger will eat the smaller. So we say stack dot append pre again, right? A gets annihilated, then we'll break. Otherwise, if it's smaller than 0, then the pre will be eaten by the current asteroid. So then we have to do it again, right? Have to do it again, do it again, do it again. Okay, so now what? If we break out, that means we're done with the current situation. We will not be done with the current situation if the entire thing gets run, right? So we'll do an else. Else means we go through the entire thing. This a is just too small, right? As a very large negative value, and just keeps whatever is in the stack gets popped. And then when we come out is when this while gets false. So while gets false, either we popped everything from the stack or we have something negative. So when that happens, we do stack.append a. So we do that, eventually we're gonna return stack. Wait, where is stack? You didn't even do stack in the first place. Okay, yeah, I have confidence. Let's try and see if this one works. For the test cases. Yep, looks okay. We need to try, try this. Okay, and then try the negative and a positive, for sure. What else can we try? We try a giant negative and a small positive. No, we tried that already. A giant positive and a small negative. Okay. Looks good. Can we make this a little bit, it looks ugly, right? This code looks ugly. Huh. You know what? I'll just try it. Let's see. Last time done is 2020. Okay, pass. I think I'll probably add a few new test cases for this. This was in 2 years, 9 months ago. Stack for this, while this, and this, if this, elif, break. It's alright. It's alright. It do the while. Oh, asteroid is smaller than 0. So I already handled this. So this if condition can be combined into this. Okay, that's fine. 275 test cases. No, it's still 275 test cases. I think the additional if, you know what? So this is solution 1, right? Yeah, because we know if is quite slow. So maybe it can make it faster. Let's summarize this one first. 735. Use stack. All right, so let's do a solution 2, which is, exactly the same, but we can say we can combine the initial, the first if check, if else, into, combine it with the while loop. Right, so we combine this by saying if this is larger than 0 and a is smaller than 0, right? So that's the case. A is smaller than 0. So if a is larger than 0, you don't enter this, you go this one directly. So we can delete this and put this back. Okay, let's try this. Did it work? Yeah, slightly faster, but yeah, this is not a major change, so that's fine. Okay, so we're done with today. That's good. Using stack. All right, let's do one more. What's this? A number of adjacent elements with the same color. There's a zero indexed array. There's no nums. This is not nums. It's called queries. That's wrong. Of length n. Initially, all elements are uncolored. Oh, I think you're returning nums. My bad. You're returning nums. All elements are uncolored. You are given 2 integer array queries, where queries I is integer and color. For each query, you color the index I, okay, with a color in the array. Return an array answer of the same length as queries, where answer I is the number. Answer I is the number of adjacent elements with the same color after the ith query. Jesus, man. Let me read that again. Answer, okay, so what we want to do is answer I is the number of adjacent elements with the same color. So adjacent elements with the same color. So every time you color, you are putting some value, some position with a value, right? I mean, we can call it color, but essentially you just say at this position, you put this value. At this position, put this value. So what we want to find out is after the ith coloring, the total number of adjacent elements with the same color. What if they are different? Wait, hold on. Small formula is the number of indices j such that within this nums j equal to nums j plus 1 and nums j is not equal to 0 after the ith query. So what we want to find out is adjacent elements, number of adjacent elements. Okay, let's see the examples. I probably want to try here so we have 4 positions, right? So we have 4 positions, 1, 2, 3. So initially 0, we color it to 2. Okay, the count of adjacent elements is 0 because there's nothing adjacent. Next one, I color position 1 with 2. So what is this? Then the count of adjacent elements of the same color. So this is like adjacent elements, right? 2 and 2. This is the adjacent elements. The number of adjacent elements, that's 1, okay? And then the third position we color 1. So this color 1 doesn't change. The fourth one is the first position, color 1. So we change this 2 into 1. Okay. So once we do that, the count of adjacent elements becomes 0 because there's nobody's adjacent. And at the end, we put this as 1. Then it becomes 2 because we have 1 pair, 2 pairs. So the number of pairs, right, of adjacent elements that have the same value. Now, my question is, if this one, if it's this, what's the answer? It should be 1, 2, should be 3, right? We can actually give this a shot. because I want to make sure that it works. So basically what we want to do is 0 is 2, 1 is 2, 0, 1, and we can do 2 is 1, 3 is 1, 4 is 1. I think, yeah, that's what we want. Okay, so the last one is 3. Yes, the last one is 3 because I'll have 1, 2, and 3. Okay. 0 is this. Query 0, where 0 denotes uncolored. After this, okay. 10 to the 5th. So what we want to find out is the number of adjacent. So what do you think? If I can keep track of I mean, every time you change value, right? You can look around. I'm trying to think. If I keep a list. Keep a list. Now I'll keep a dictionary, right? And say color 1, how many pairs? Okay, I have a value. Color 2, how many pairs? Okay. Then I make a change. Right? I make a change. I make a change in this position, right? I'll need to change this position, and it has adjacent on the left, not right. So whatever the value, we have some value on here, like we have value 1 on here, let's say value 2 is here. So if we add a value 1, then no matter what, the number of pairs for value 1 will increment by 1. And of course, you also need to know what value is here, right? The number of pairs. If its value is 2, then the number of pairs on number 2 will decrease by 1. Number of pairs of 1 will increase by 1. So you can change it, right, accordingly. Okay, so if both sides are 1, then you add it, then we can form 2. We can form 2. So what I'm saying is we'll keep track of the total number of pairs, right? So we initially 0. Well, with 0 we put into 2. Okay, let's do this one more time. We put a 0 into 2. Now we check, right? We check left. Well, left is nothing. Check right. Right is 0. So they're not the same. And then the colors start from 1, right? So this nothing with 0. Now we do 1 is 2, right? We do 1 is 2. We put this as 2. So when this is 2, we check around. Nothing here, but here is a 2, so we add 1 plus 1. So we have a 1. Now we put this as 1, check around, nothing happens. We put this as 1, right? So we first check around, we have to remove this. So we decrease by 1, so it becomes 0. And then we look around, nothing, so it's still a 0. Next we put 2 to 1, so we put 2 to 1 both sides, so this one plus 2. Yeah, I think I might be able to do this, just, walk it through. Straightforward, walk it through. I think it shall work. here's the solution. We'll just walk it through. We do a result, and we do have to do the nums, right? We have to do the nums times n, and then for index color in queries, we have to first find out if index -1 is larger or equal to 0, right? And then we need to check if the two, and if nums index is equal to nums index -1, right? And nums index is not equal to 1, not equal to 0. If that's the case, then well, I suppose we should start with 0, right? And here's the first one. Yeah, I think it'll be easier to do this. Nums queries 0, because queries, the length is 1. That query is 0, 0 will equal to queries 0, 1. And then we can say for I in range queries. Now I can still do index color in queries 1 to the end, right? So if this, then we say current shall equal to, or we can just do res dot append -1, right? And then we say res -1 shall minus equal 1, because it's equal with previous, right? We compare to the left. If it's equal, anything else, if it's not equal to, or if the current one is a 0, then we don't do it. So we do that if it's larger equal to 0, and then I'm not changing it yet, right? I'm not changing it yet. Then we can say if C is equal to nums index -1, right? So that the one added to it is the same. So now we're gonna plus equal 1. All right, if this is smaller than 0, then we don't do anything of this. Another one is if index +1 is smaller than len queries, okay? Again, we say if nums index is equal to nums index +1 and nums index, right? Means it's not equal to 0. When that happens, because you want to remove whatever I have right now, then this will minus equal 1. And we say if C is equal to nums index +1, right? It's equal to on the right hand side. Then res -1 plus equal 1. So we'll do this, then we'll return res. Honestly, I don't have as much confidence as the earlier one, but I might as well just try it. And see if it works. If it doesn't work, we go back to the, here we have a list out of, that is strange. Yeah, we have to check. It's okay, no hard feelings. It's all right. We just need to double check on this. Most likely is the second test cases. It's the second test case with only 1. Just have to figure out, because this is 1. Okay, that's really weird. All right, so first one's n, now we have queries, color, and queries. Yep. Index out of range. That's really strange. Why would index out of range? Because I already checked. I mean, oh, because queries. Oh, I know. This is from n. My bad, my bad. Okay, so it's almost right. Okay. We got 0 right, 1 right, and this should be 0. Which is this one? This one is 0, 1, 2, 3. The third 0, 1, 2, 3. The third is we push 1 into, so initially is 2, right? So initially is 2. I check -1. So I think this -1 is correct. And then I need to check if it's equal to. But now I'm a 1. The previous is 0, so this shouldn't add. And then I check on the right hand side. Right? I check on the right hand side. And the right hand side right now should be a 0. So if this is equal to, no, this is not equal to. And if C is equal to on the right hand side, C is a 1. So I don't understand. Well, that's fine. So what we want to do is let's just print res. Just kind of take a look how it looks like. Okay. So you go to 1. Oh, I need to print also nums. Oh, I think I forgot to do the num. Dang. Okay, I think I know why. I forgot to update nums. Index equal to C. There we go. Yep, I forgot to update. Now that makes sense. A little bit oversight. Okay, this one shall pass. Come on. Yep. Pretty straightforward. This one is pretty straightforward. For each query, check its left and right and decide whether we need to update the total count of pairs of adjacent values. That's ON. Okay. Simple counting. Yeah, you can do that. You can do that. Yep. Oh, yield. The hell. Jesus. Well, it depends on how it's checked. All right. I mean, I have to say this does look better. It's okay. Yeah, I like this one. This is actually a good one. If it's right. If else return 0, that's a good one. So immediately you get the pre and next. Once you get pre and next, the remaining will be simpler to handle. Okay, so that one is done. We can move on. What's the next one? I can just press the next. Oh, I've done this one already. So I can press next, 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 next. Okay, this is the next. But that's JavaScript. I don't want to do JavaScript. Okay, this is the next one. All right, I'll do this sometime else. That'll be it for today. Half an hour, not too bad. See you guys tomorrow. Adios.